And then let's first take a look at how to create a data frame by ourselves. So Pandas has many methods to create a data frame. In particular, we can do the following. So first, we can create an empty data frame. Just use the data frame function parentheses, then it's empty. We call it data frame 2. And then we can define each column one by one by ourselves. So for example, we first define a column called name, and then enter the values in this column. Suppose we only want to create a very small data frame with 2 rows, 2 observations, so 2 names. And then the corresponding ages of the 2 individuals. Okay. And then whether or not the person is the driver in the car, for example. So it's a logical vector. So notice that in each assignment segment, we specify a list of values for each column. And then let's run this. So data frame 2 is a mini data frame, 2 rows, 3 columns. So this is a simple way to create a toy data frame by ourselves. So sometimes you just want to test a very simple model, or you just want to have full control of your data frame, then you can create it by yourself. All right, now let's see how to describe a data frame. First, you can show or view the first few rows. So we have seen this. The head function can be used to show the first few rows. By default, it will show the first 5 rows. And for example, the first 2 rows of Titanic looks like this. We can also show the dimension. Dimension is the shape, number of rows and number of columns. So the Titanic data set has these many rows and 6 columns. It's a very small data frame, actually. And you can also calculate some descriptive statistics for a data frame. So in Pandas, there is a function called describe. So Pandas data frames have this method, associated method called describe. And by default, it will only focus on numeric variables. So it will automatically ignore categorical variables. Categorical variables are variables with values that are character strings. So for example, if we call the describe method and apply on data frame 3, which is the Titanic data set, you will see this, you will get this table. So for each numeric variable, the function will calculate the number of valid observations, non-missing values. So for age, there are 756 of them, survival, and sex code. So these 2 variables don't have missing values, but age has missing values, a lot of missing values apparently, right? And it also calculates the mean and standard deviation for each numeric variable, and also the 5-number summary of them. So it's a very good way to summarize your numeric variables very quickly. Have a very quick look, and you can also see how many missing values there are. You cannot tell, actually, you cannot tell. Yeah, so this is just the number of non-missing values. You have to combine the information that you got from shape, the shape function, to check if there are any missing values. And so this is a summary of what we have seen, the head function. And the tail function is similar to the head function, but it will show the last 5 rows by default. And just pay attention when you look at the summary statistics that you get from any functions, pay attention that some categorical variables are coded as numeric variables, like binary numeric variables. For example, sex code. Sex code is numeric. It has only 2 values, 0 and 1. But Pandas functions don't know that it is actually a categorical variable, so it treats it as a numeric variable. That's why it calculates the mean, standard deviation, and the five number summaries for it, although they don't make much sense for this variable. So in this case, it's better to either recode it, encode it into a real categorical variable or a factor variable, or you can use some other method to summarize this column. All right. The describe function actually can be used to summarize categorical variables too, if you specify include equals all, like quote all. So that means you want to describe all of the variables, including categorical variables. Okay. So for example, name, passenger class, and sex. So these three are categorical variables. So for categorical variables, the information that is provided by the describe function is very limited. You can see that it only provides a number of non-missing values and the unique values for the variable and the top category. Top category means the category that has the most observations, most number of observations, basically the mode of the categorical variable, the most frequent category. So apparently for name, the name variable, there are two rows corresponding to this person. In this case, Connolly, there are two observations. Similarly for passenger class, there are four unique values. And the top category is the third class, which means this class has the most number of observations, the biggest frequency, which is 711. Okay. And for the mean and standard deviation and five number summaries, so it returns missing because, of course, we cannot calculate these for labels, right, for categorical variables with label values, etc. So you can force the describe function to describe your categorical variables. However, the information provided is very limited. And a better way is to use some other functions. And another function to have a big picture of your data frame is the info function. Let's run this. So the info function will tell you the class of the object. So our data frame 3 is a pandas data frame. And number of entries, which is number of rows, and the row indexes, and number of columns. And then for each column, it shows you the number of non-missing values and and the data type of the column. Right? Object is kind of anything, basically is categorical. Right? Is categorical. And float, a real number. And integer is integer, numeric integer. So you can have a very good idea about the entire data frame, right? Especially the number of non-missing values. So this is very important. For example, in this case, age has a lot of missing values. You can choose to delete observations with missing values in age. However, by doing so, we will lose a lot of data points. Right? We might not want to do it. In this case, we probably want to figure out a way to impute missing values in this column. If there are only a few missing values, for example, 1, 2, 3 missing values, then we don't bother to do it. We can delete it because we have not very small sample. We have 1,313 observations. It's not too small, so we can delete a few observations. We can afford that loss, but we cannot delete like hundreds of observations because we only have about 1,000.